Hello everyone. In this lecture we will be seeing the reinforcement learning. So this is where machines learn through trial and error, much like how humans learn to ride a bicycle or play chess. So by the end of this session, you will understand how this powerful uh, learning is behind everything from game playing AIs to self-driving cars. So we have seen the supervised learning, unsupervised learning, and now we'll be seeing reinforcement learning. So see, supervised learning is like learning with a teacher who gives you answers, and unsupervised learning is like exploring on your own. This reinforcement learning is more like learning to swim. That is, you try different actions, some work better than others, and over time you develop an effective strategy through feedback from your environment. Okay. So imagine teaching a dog new tricks. When it does something right, you give it a treat. When it makes a mistake, no reward for this, right? So reinforcement learning works the same way. The agent takes actions in an environment, receives rewards or penalties, and gradually learns the best strategy or policy to maximize its long-term rewards. So this delayed feedback is what makes it both powerful and challenging. So if we see the components of this reinforcement learning, it has four main components. That is the agent, environment, actions, the reward signal that guides the learning. So first you think of a video game where the player is the agent, the game world is the environment, the controller buttons are actions, and the score is the reward. So here how the magic happens is that how the agent connects these dots to improve its performance. Okay. So, if when playing a long game of chess, how do you know which moves led to your eventual win or loss? So, this is called as a credit assignment problem. The agent must figure out which of its many actions deserve credit for the final outcome, right? So, it's like a soccer team analyzing which passes ultimately contributed to scoring a goal. Okay. So some of the real world examples we will be seeing this. What is this positive and negative reinforcement learning? Okay, some of the real world examples we think of AlphaGo, the ancient game of Go, robots learning to walk through trial and error, inventory management systems optimizing the stock levels, personalized recommendation systems that adapt to user feedback. Okay, so next, if you see the main important algorithms in this reinforcement learning is that is Q learning algorithm. So this is one of the fundamental algorithm for this reinforcement learning. Imagine a robot in a maze. So Q learning builds a table that estimates the expected future rewards for every possible action in every possible state. Through exploration, it gradually fills this table, learning that some actions in certain states lead to better long term outcomes than others. So it's like the robot building the mental map of which turns typically uh, which leads to the which leads the closer to the exist. Okay, and then in this we have deep queue networks. So when problems become too complex for the tables like video games with millions of possible states. Here we use neural networks to approximate the queue function. So this is how the DeepMind's AI mastered games by looking at pixels and learning which actions maximize the score. So it is much like a human player would, but with superhuman patience to try every possibility millions of times. Okay. So this is example of the reinforcement learning where it's a game of game playing. So where for each move, the agent gets the reward and the penalty. And then we have inverse reinforcement learning. Sometimes it's easier to show that show than to specify the rewards. So in inverse reinforcement learning, we observe an expert's behavior, that is like a skilled helicopter pilot, and work backwards to determine what reward function they must be optimizing. So it's like watching a chef cook and trying to deduce their recipe. So we learn the underlying objectives from the demonstrations. So you could see here, I'll show you an example of how this helicopter in air shows, autonomous air show and autonomous shows. So what we could see here is this is the show where we have challenges and limitations for this. So this often requires massive amounts of trial data. Right? So where this show is good, and the exploration process can be dangerous in real world applications. So for example, if you see this shows autonomous, so here now you could see the shows. So reward functions can be tricky to design correctly, and results can be unpredictable during the training. So where we have seen this cutting edge applications like autonomous vehicles learning complex driving strategies that we have seen now, AI assistants that adapt to individual user preferences, smart grid systems optimizing the energy distribution, robotics controllers that learn delicate manipulation tasks. So reinforcement learning, which represents where the machines learn by interacting with their environment, much like biological intelligence does. Okay. So it's behind some of AI's most impressive achievements and continues to push the boundaries. Thank you.